Okay.
Thank you so much for joining us today. Would love to kick off the podcast by you telling me a bit about who you are, what you do, and how you got involved in the AI world, in the AI space we're in now.
I'm chief scientist of IBM Research, and I have a very broad role, but my journey into this started with very much with my sort of research topic way back in early 90s. My background is in algorithms, which are the foundations of almost everything that is happening around us, but even more importantly, AI actually. And in particular, my journey in AI started in 2011,
Okay.
way before ChatGPT was even a word, actually, decades before that, where I was accelerating analytics workloads on GPUs
Okay.
before NVIDIA was on its sort of hyper trajectory as well. And then over time, I took the role as CTO of Watson for 4 years. And then I came back into research in a broader role as chief scientist and have been involved in AI for last more than 15 years now.
It's incredible. I was looking up your LinkedIn, and very few people have LinkedIns that leave me that much in just shock about like, wow, all this experience. You started IBM, what, 30 years ago?
31 years to be precise.
That is incredible. And in the first role, again, I was super surprised to see that it was autonomous algorithms. I feel like that's a word we would hear in every press release, press conference, keynote today. But 31 years ago, that's what your role was. Can you tell me a bit about what it looked like then compared to what that same kind of role would look like now?
So, as I said, I've been in the business of, if I may say, like automation for 3.5 decades. Before any of the word of AI was, actually, we were deep in the winters of AI at that time. It was not something that you will utter in an interview.
Right.
It's something you hid from everyone else that you ever did it. And back then, I think we went through a couple of phases, actually. It's not that, obviously AI itself the word was coined in that famous meeting in Dartmouth, New Hampshire, where 16 people and a couple of IBMers were there as well, where they coined the word of artificial intelligence. But sort of the underlying sort of foundations of it have been algorithms like what is known as gradient descent. If I may describe that algorithm in its simplest form, is like you are trying to traverse a complex hilly terrain, and you're trying to get to a lowest point in a valley.
Okay.
But you can't see. You can't see around because the lowest point in the valley is somewhere, actually. Like you are standing on a small hill, and it may be beyond a big mountain, down the slope, somewhere, actually. So you say, okay, what's the best path you follow? You look around and say, what's the steepest path? And then you go there, and then you keep following the steepest path, and at some point you say, I think I'm stuck in a kind of a local valley. And then you randomly sort of somehow hop on a drone and get dropped somewhere else, actually. That's the best way to describe that algorithm, actually. And that is kind of the foundation of, in sort of really, I'm oversimplifying it, but that's the foundation of how we train these models with a massively large data. So what has happened over last 3 decades is that, at that time, we had neural networks, yes, but we didn't have big data. Like the data, internet had not exploded yet. So you had, there was no data available. So you had more analytics kind of, very precise algorithm for predicting things. Neither did we have big compute. So what has happened is that sort of since then, 3 things have come together. There was internet explosion that happened.
Yes.
Which resulted in massive amount of data, actually.
Yes.
Okay. If you have massive amount of data, then you are kind of handicapped if you don't have enough compute to process it.
Of course.
So, some researchers figured out in a lab in Stanford that, hey, these GPUs that work on graphics work very well on matrix computations. So now I can take this big data and marry it with big compute. And there were some advancements that happened in sort of AI techniques as well, in particular transformer architecture, which is now the foundation of the entire large language model area, arrived as well. And these three things, when kind of married together, results in this phenomenal breakthrough. None of that existed back then. So that's the main difference. I would say big data, number one, big compute, number two, and advancements in algorithmic techniques as well. That's really the sort of the supernova you're looking at right now.
I'm curious when you yourself felt a shift. You were like, this actually has potential to be so much more than it is now.
I would say 2020.
Okay.
This was pre-chat GPT.
Right.
Many people in certainly IBM know it, outside know it as well. I had predicted, this was back in 2020, not just a shift. I said, I think AI is going to change coding. It's going to fundamentally change software. And I said, since every company that we know of today is a technology company and a software company. Like, no, the world around us is software.
Yes.
Whether we don't feel it as software because we consume it as services, but underlying it is software. Every bank is a software company. Every logistic company is a software company. So software is everywhere. And if we could do something more fundamental with software, we'll change the world. And it was back in 2020, I was working on, and most people in IBM know it actually, that I was working on something called AI for code. Okay. That, AI is going to change coding. And why? You may ask, why is that the case? Because in software, we are blessed with the fact that there's something called verification. Software is not kind of right. It's either right or wrong.
Yeah.
Language is kind of different. Language is a lot of gray zones in between.
Yeah. Interpretation.
Your interpretation may be different than mine, but software is like if you produce something, you can verify it.
Right.
And that verification is golden actually, because then you can say, hey, these were the errors I got. You produced something, you ran it, you kind of verified it and say, these are the errors I got. You send it back and say, correct these errors. So there's a closed iteration loop that can happen, which is kind of a blessing in software. So you may say, where was my aha moment? I'll say, I was playing with these models at that time, which were, I would almost say, 2 to 3 orders magnitude smaller than where we are today. Yeah. And it was kind of the moment for me on, I think this is going to change the game. And I remember grabbing lots of, if I may say, sort of authorities in the area and say, this is going to change the game. And they say, nah, I think you are hallucinating. And because I think what happens is that if you are in the particular area for too long, then you can't see the disruption coming easily because you know the ills of the area too many of them. So like we took it upon myself to gather massive amount of data that we now call CodeNet, which has actually got into alpha code from DeepMind and many others as well, which to me was this sort of, as I said, I remember telling people who were responsible for a lot of software in our business, this is going to change the game. And I think they partially saw it and say, you said this is going to take my job. And I said, not exactly. That's not what I meant, actually. But I really think it's been 6 years for me, for which it was clear to me that I think we are in for a massive transformation, actually.
I would ask you about all of the positives and the potential use cases and the potential disruption, but I think at this point, we've all seen it. We've all either interacted with a chatbot to a smaller degree or used it or implemented in a workflow where we've seen the positive impacts and we know that they're here and we know that disruption's here. We see from positive cases where people, like today when we found out about the quantum example and, something that could not have been done before being done now. We've seen that, but we've also seen the negative use cases where like people's jobs are being replaced, people are being laid off, all of that. So instead of focusing on the impact, would love to pick your brain a bit about the actual algorithm, since that's what is your bread and butter. What do you think? Do you think there's a world or any research that it's possible to be done, or how long do you think that would even take to start eliminating some of those algorithmic hurdles that we have right now? For example, hallucinations, for example, being overly confident, all of those things. I'm sure you've seen them from the beginning, and now there's still an issue. When do you think it'll be the next step there?
So I think there are, I would say, two fundamental issues or two fundamental aspects that is still a hot topic of research. One is, I will say, so let me step back and say, knowing what you know is retrieval. It's in your memory, you retrieve it. Good, that's maybe part of the intelligence. Knowing what you don't know is intelligence.
True.
Like, I don't know this. There are not many people who acknowledge I don't know this, but internally everybody knows what they don't know.
Right.
Whether they say it or not is a different thing, actually. I think it's kind of hard to lie to yourself because you know what you don't know. And in my mind, these models are still learning to model what in technical terms or algorithmic terms is called uncertainty. When was the last time you or anybody else had the experience with a chatbot or a large language model saying, I don't know? They always tell you an answer. And then if you push them hard, they'll say, oh, I'm sorry, actually. I was incorrect, actually. I think it has happened with each and every one of us. And this, to me, is a fundamental aspect of research that we are doing in IBM Research and lots of institutes in academia and other industry frontier labs are doing as well, which we call the ability to be able to model your own uncertainty and to be able to reason with that uncertainty as well. So that's one aspect. I think the other one is, I would really say, one aspect that's fundamental to humans is self-improvement. You start from a certain point, you continuously learn from things, and you continue to self-improve. Where large language models are still today are at a point where they're given a certain intelligence, and like you get what you get, and you kind of don't get upset. They are at a certain intelligence, and you wait till the next release of the model, or chatbot, or I would say agent, for you to get the next level of intelligence. Humans are not like, you see Ruchir today, and Ruchir may have a different version 9 months from now. That doesn't work like that. I may be different and continuously improving, including from this discussion we are having, and my responses next time around will be informed by the journey I'm going through all the time. That is actually called self-evolving on a continuous basis. That is another foundational aspect that we are currently grappling with, dealing with in research. So obviously, tremendous amount of progress has been made till date on making AI useful.
Yes.
But still, large gap remains on bridging the gap to, I would almost say, making artificial as good as real. And the third aspect I would say will be, I think everything in the world is about efficiency. And I'll elaborate on that a little bit. Efficiency is, so given the energy of sun, everything is possible. In this world, given the energy of universe, everything is possible. But if you look at our own intelligence, so let's look at this. Whenever there is something artificial, there must be something real, right? That's why there's artificial. Artificial doesn't exist in the absence of real.
For sure.
That real is sitting between these two ears, sits in 1200 centimeter cube, right here. Consumes 20 watts. 20 watts, the power of a LED bulb on your phone, and runs on sandwiches.
Yeah.
That artificial, a single GPU, NVIDIA Blackwell 200, consumes 1200 watts. 60 times more than your brain, and you need hundreds of them to thousands of them to do even partially what a brain can do. That is the gap you are looking at between artificial and real. And that's a journey we are on to make intelligence more and more efficient. Actually, Stanford had a very nice paper recently called Intelligence Per Watt. I think that's the third leg of we got to make it more efficient. I just take objection with, I need the power of, city of Columbus, Ohio to run. Like, this is just not heading the right way. Now, we are brute forcing it. That doesn't mean to say that's where we will end up.
Yes.
So those are the three major things I would say. Those are the gaps remaining where we need to get to. And the energy efficiency is a fundamental one, actually, where you can address it with two aspects. You have infinite energy available, like fusion. You address it with energy aspect. Hey, I make energy free. You can see with all the geopolitics going on, energy is not free for sure. Or you can make intelligence more efficient, which is aspect I think collectively many of us are working on as well.
I would love to double click on the intelligent aspect of it all, because what these models are doing, and I'm definitely oversimplifying, I would love to hear your take because you could explain it much better, but they're essentially taking all this data and then they're analyzing it and then making predictions, right? Based on like the patterns. Well, as you said, that's part of what we do. We recall our prior experiences, our education, our learnings, and then use that to make a decision. There's also a lot more factors than just, recalling data, right? We have our own experiences, our biases, our emotional process, all of that. So that's what I would say is more akin to what I would call intelligence or thinking, reasoning. Will there ever really be a way to mimic that artificially? To your point, to mimic what's in here and put it in a chatbot or an artificial, algorithm, when it can't do those things.
So I think you're going to something very fundamental, and I've said this for I remember interviews with many media sources 10 years back on kind of where will intelligence be, and I said, what is intelligence?
Right.
In my mind, intelligence comprises of three things. One of them is very well known and everybody talks about it, called IQ.
Yes.
Intelligence quotient. I think AI will nail IQ, literally will nail IQ.
Of course.
And the second aspect is EQ, emotional quotient. I think we would all agree. Let's consider successful CEOs or CEOs of most corporations. Actually, we would agree all of them are highly intelligent people, but all of them have amazing EQ, at least all the successful ones, but they may not have the highest IQ. I don't mean to say they have bad IQ, not at all, actually. I mean to say they may not be the geniuses of the world, actually, what is known as they're amazing people for doing strategy, really dealing with large organizations and people. So it needs a mix of these multiple quotients. And the third quotient that doesn't get talked about as much is what I call RQ. RQ is relationship quotient.
Okay.
It's kind of related to EQ a little bit, but not exactly. How good you are at forming and growing the relationships. Which again, I think it benefits from the other two, but it's a separate factor in itself. Combination of these, IQ, EQ, and RQ, gives rise to intelligence. I think AI will nail IQ.
Mm-hmm.
Still far away from EQ, I would say.
Yeah.
Because EQ is more like, you can see somebody is distressed, you say, give me a hug.
Right. And it's also subjective, right? Because everybody kind of handles it a bit differently.
Yeah, everybody handles it a bit differently. It's very contextual. We haven't matured yet to a point where a machine giving us a hug will calm us down.
Yeah.
Not yet. Maybe someday we will. But I think just the power of human touch and human emotions is something that is just innate in us as humans.
Of course.
Now, the machines may become amazing at automation, actually. I think they'll get it really infused into every aspect of our daily lives. But these aspects of EQ and RQ still remain a goal for us. And that to me is part of intelligence which we need to continue to work on. And I don't think we may be able to predict emotions, by the way. It's certainly possible that I can predict somebody is distressed. But to be able to sort of deal with those emotions, calm themselves down, give them a hug, I think humanity is a lot more than it can be captured in tokens.
Right.
Lot more than that, actually.
Yeah.
I almost feel like there's kind of a field around each one of us where you don't have to say anything. Like no tokens exchanged. I didn't say anything, actually. But the other person knows what I'm feeling. Like there is no such thing as of yet. And then there are people, like Jan LeCun and others who are talking about world models. So I think we will all agree token-based intelligence gets us to a certain point.
Right.
Which is language. I think language has a massive implications and it has done amazing. But the real world around us is a lot more than that can be captured in tokens. And that's the part I think we are still missing in terms of whether it is world models, how do you model the world around you, or other technologies that are still gaps and unknowns that remain.
We've talked about a lot of challenges from actual intelligence ones to like the emotional aspect. Which one do you think is the most important we tackle now? And which one are you the most hopeful will get tackled soon?
I think the one we must tackle now are the two aspects that I mentioned among the three: uncertainty modeling.
Yes.
If these technologies were to become useful, they need to reduce, I'll call, more of the lying, also known as hallucinations.
Yes.
If you hallucinate a whole lot, I think you're lying, actually. But lying is something that you know that you knew it, you're still saying it, actually. They don't know it, actually.
It's almost scarier, right? Like almost having a pathological liar, right, around you all the time. They're not even aware they're doing it.
So I think we need to address that particular aspect of knowing what you don't know. That is urgent, that is here. And it's, again, as I said, it's a very, very popular topic of all leading conferences in AI area. You go to NeurIPS, you go to ICML, you go to ICLR, and many other conferences as well. The second one, I think, which is after that we need to, so urgently, we need to address uncertainty modeling, knowing what you don't know. The second one we need to address is, this starts leading us to efficiency, self-evolving, learning from your experience. Because then you would not need the power of a gigawatt farm to be able to feed it. If you are continuously, we don't need gigawatt of power actually attached to us anywhere. We are running on sandwiches on a continuous basis, and we are improving on a continuous basis as well. I think that is the second one. And the third one is, I think that relates to more of a hardware technologies and computer architectures, on starting to work on technologies which are more in semiconductor chips and computer hardware and accelerators, on how do you make these foundational components of intelligence or artificial intelligence lot more power efficient as well. I think in that order, I would say, address uncertainty now. Second, as you start to tackle it and reduce hallucinations, you start to improve on self learning and adaptation. And the third one is longer term, continue to close the gap between this real and artificial.
Despite everything we just said, I still get the sense, and from your commitment of really working in this for so long, that you are still invested in the potential that AI can have, the potential AI has now, and that you're still somewhat bullish on AI. Why is that? What makes you still confident despite all of these challenges?
So I would say, I'm a huge fan of a word that sort of I coined called AUI. There's a lot of people talking about AGI. I kind of roll my eyes a little bit because we don't even know, as we talked about, intelligence is multiple things. So this general intelligence is kind of bothers me a little bit. So I like the word AUI, which is artificial useful intelligence.
Oh.
Can somebody make it useful for me? That's what I care about. It's useful. And in that vein, I am not just optimistic. I'm very bullish on AI technology to be useful on day-to-day life. It can make somebody who doesn't speak a language converse in that language. It can make my customer experience much better. It can make tasks of software that many people found kind of very tedious more efficient. Those are all amazingly useful things that are there in our day-to-day lives, actually. Whether we have achieved AGI or not, leave that aside, actually, totally. And that's why I am extremely excited about the power of AI technologies to be useful today. And I think Arvind talked about it earlier in the morning as well, that there are two ways of approaching it. One is, what we will term as plus AI, which is I'm given a task. I'll say, how can I do that task a little bit better? Oh, I can infuse AI here, I can infuse AI there, and I'm better. That to me is incremental. The second one is what Arvind described as AI plus, which is if I knew AI technology existed, will I do this task completely differently? Like literally reimagine this task as well. That to me is the true promise of AI technology. I think lots of companies today are invested in making plus AI, which I would say yes, it'll get you some productivity improvements and impressive ones too many times. But if you want to really change the game and get really massive jumps in productivity and usefulness of the tasks, then you need to shift to reimagining the business processes and the tasks themselves. Which again, we are doing this in IBM, we are doing this in research for things like quantum itself as well, actually. How do we discover quantum error correction codes? Fault tolerance in quantum is I would say a major milestone that we have said will occur in 2029. How can AI help us get to better error correction codes? How can AI help us compile the quantum codes much better, actually? How can AI help us literally reimagine how we calibrate these systems as well? How can AI help us do chip designs much better? In terms of just reimagining the whole process, not just AI can help me do one algorithm better. If I were to do this all from scratch, what will it look like? Those are the things we are deeply invested in to make these technologies not just useful, but really redefine the era of how these tasks are done.
Well, on that positive note, I think it's a great place to wrap up our conversation. Thank you so much for your time. This was really insightful. Thank you.
Thank you. Appreciate it.